If you go to A2 tab, you'll see all these questions that we're going to answer. Now, so we know how to find the optimal solution. Now we should be able to interpret what we have, and also ask questions like, what if this number changes? So what if that number changes? Then what will happen to our solution? Do we still do the same thing, or do we have to do something differently? Something different. So we're going to do that by answering, these questions. So what we're going to do is we're going to keep copying the sheet over and over and over. So because some of these questions, we're going to make changes to our data in our model, and we want to keep the original result, and we also want to have the new result to show. First thing is, so let's take a look at the first couple of questions. So according to the LP linear program result, how much of each product should be produced, and what is the maximum possible profit? So this is the first thing you should say after you solve a linear programming model. Like, what is the result? So what should we do? What is the recommendation? And then what do we get from it? If we do this, then what is our profit, or what is our total cost? So we'll just kind of copy this over. So we'll say this. This is our answer, so I'm going to make it bold. Okay, so here's a recommendation. Here's the optimal solution. Make 540 standard bags and 252 deluxe bags. And what do we get from this? And then we're going to get maximum profit of $7,668. And now we should also know, will there be any resources left? So we should be able to know what's going on with our resources. And remember, the slack represents a leftover resource because all these constraints represent resources. So we could just look at the slack to answer this question. And so cutting and dyeing, no resource left. Sewing, yes, there's 120 hours left. And finishing, no. Inspection packaging, yes, there's 18 hours left. So that's what I would state. So here we will say, yes, there are 120 hours of sewing, hours left in the sewing department. And there are, what else? 18 hours left. And 18 hours left in the inspection and packaging department. Okay, so that's just a matter of interpreting, just reading off the numbers, from our result. Okay, and well, actually I should put it here. Okay, now let's look at this other question. What if management specifies at least 500 of the standard bags and at least 360 of the deluxe bags must be manufactured? Then what is the new optimal solution? So 500 and 360. Well, currently the optimal solution is this, making 540 and 252. And now it's saying, okay, how about you have to produce at least 500, which is what we're doing, but then it says at least 360, which is not what we are doing here. Okay, so what we could do is we could add some constraints. So we could say something like, well, this has to be at least 500, and that number has to be at least, at least 360. Okay, so to do that, we're going to make a copy of this and make that change. Okay, so I'm going to go, copy of this, and then say yes to all. And this is number 3, and that's number 3. Well, that's convenient. And so here we're going to go, and so we're going to here. So number 3, try adding constraints. S is at least 500, and D is at least 360. D is at least a 360. So here are the new constraints. Now we're going to solve this again. Okay, so I could actually do this directly inside a solver. So I could go here, and then I could add a constraint, and I could say, what's S? S is just over here. This number, B4, that's my S. So that's my left-hand side. And then here I'm going to say greater than or equal to. So here I'm going to change this direction to greater than or equal to. So in the middle here, we got to specify greater than or equal to. Then here we're going to 500. Okay, we could just write 500 like this. So so there it is. So this is saying here's my S, here's my greater than or equal to, and there's my 500. Okay, so here I'm going to, that's this first additional constraint. And I want to add this one too. So I'm going to say add. So I could add this one, the second one. So here, what do I enter here in the cell reference? C4? C4? Oh, that's a good idea because that is a D. That is a deluxe D. And then here, greater than or equal to. And then the constraint, that's really the right-hand side. So I could just enter 360 directly in there. And so that says, so C4, greater than or equal to 360, then I'm going to say, okay. Okay, so you could see the two additional constraints here, and everything else was already there. And so what I did was I added more constraints. Now, when you add more constraints, is it good or bad as far as being able to solve the problem? If you add more constraints, you're kind of restricting, like laying down more restrictions, so it's probably not great. So profit will probably not increase. So if I'm adding more restrictions, so let's see what's gonna happen. So I can say solve, and no, this is like worse than that. So there's no solution. Oh, okay. So just not possible to solve this. So it says solver could not find a feasible solution. And so that means there are no values that satisfy all of the constraints, because a new two constraints just kind of broke it, just broke this thing. So it's not possible to produce at least 500 and at least 360 without violating some other constraints. Okay, so let's say here I'm gonna say okay. And then now you might say, oh, wait, I do have 500 and 360 here. Now, so does it mean that we actually found a solution that satisfies these constraints? Now, if you look at the slag, you know something is wrong. And so how can you have negative leftovers? And so you are using more than what you are, what is available. Okay, and so here, when you say, so if there's a message that says it could not find a feasible solution, you should take it seriously. I mean, it's being honest. It couldn't find a feasible solution. So whatever it ends up in here, it doesn't really matter, because that's not really the solution. So it means it could not find a feasible solution. There was no solution that could satisfy all of the constraints. So this is what we just did. We tried this. And as there are not enough resources to make these amounts, the problem, it becomes infeasible. So infeasible problem means there is no feasible solution. This is very common actually in real life. And so I actually took over the scheduling of the classes in my department. Now I have to make sure that all the classes have somebody to teach, some professor to teach, and all the classes have the classrooms assigned and so forth. And also a lot of requirements from professors. I find that I'm really faced with an infeasible problem. There's no way to satisfy all those constraints that are coming to me. It's very common to have an infeasible problem in real life, and it's more like a human problem. And you have to talk to people to try to make them understand, and make compromises. But in our class, we're just being introduced to this, so I'm not going to give you a hard time. And so I'm going to give you only good problems that have solutions. So you should not get this. This message you should not see. So, but if you see this message, then whose fault is it? Not my fault. So it's probably your fault. So you probably made a mistake. So if you see this message while you're doing your homework, then you need to go back and check. Okay, and the objective cell values do not converge. Oh, so let's talk about this. If you make some mistakes somewhere, then you might get some message like this. So for example, let's go over to A2, and make another copy, and we'll say yes to all. Okay, so this is the original problem I made a copy of. Okay, so what if I did this? What if I, instead of doing less than or equal to here, I did greater than equal to. So but if I mistake, so let's say I make a mistake, and let's go over here, and I make a mistake here. So here I'm gonna change it, because I'm pretending I am making a mistake. So greater than or equal to, is it greater than or equal to, and then, so if I change this to greater than or equal to, and then say okay, and then I try to solve this problem, then what happens? It says the objective cell values do not converge. Objective cell values do not converge. Oh, so you could see that there is something wrong. So again, you probably made a mistake, and you probably need to find the mistake and correct it. Okay, and so in terms of, so again, you get something in here, but it doesn't mean anything. So if you get an error message, then whatever shows up in this in these variable cells are not the solution. You just ignore it. So what's going on here is, in that case, if I change this to from less than or equal to greater than equal to, so then what is going on is now the arrows are going the other way. They're going this way. So all these arrows are going this way. So what we have is like now the feasible region is all this. So kind of starts over here and it just goes on forever. So that's why it's saying it's not converging. So there's no point where you could settle down, but it just keeps going and going and going. Okay, so that's what it means when this says objective cell values do not converge. And then sometimes in the objective cell, so it might say the objective cell contents must be a formula. I mean, objective cell over here is over here. So this is what you need to select. But sometimes, so let's say I go over here. When I go to solver, and like when you go to solver, it's selecting this part. Okay, let me just click on some empty cell. Okay, okay, so then it says must be a formula. Okay, okay, so here just make sure that it stays locked at your objective cell. So we did 3 and 4. So we did 3 and 4, and now we want to look at 5, 6, 7, and 8, or maybe 9. So 5, 6, 7, 8, and 9. Okay, so what we'll do is, again, we're going to get the A2, and then we're going to make a copy. And let's just make a few copies. So, okay. I made let's see. I think I'm going to make maybe 4 or 5 copies. Okay, so let's see. So this one I already messed up, and that one, A5. Okay, so I'm going to go with this one. Okay, so 5 is over here. Okay, so let's take a look at this. And so it says, if 50 additional hours become available in cutting and dyeing department, what would be the maximum profit? What would be the effect on the maximum profit? So 50 hours become available in cutting and dyeing department. So what does that mean? So it is saying cutting and dyeing department, so this is what is available, 630. And we're saying that if this number could be higher, like by 50. So if this becomes, or this one, this becomes, 60. Becomes a, add 50, and what do I get, 680? All right, so add 50, I get 680. So then what will happen to the profit? If we have more resource, then what, is it good or bad? More resource, good, yeah. So if we have more to do things with, then maybe we could make more of our product and make more profit. Okay, so let's see what happens. So it is 7668. So the 7668, that's the original profit. And I'm going to write down here 542,250. So that's the original. So just we have it there. So 542,250, here is a total profit. Now, what I'll do is I just have to go over here and then change it to 680, not 60, but 680. 680. And I'm going to just highlight this to to just remind me that this is what I changed. So I changed it from 630 to 680, and then I would just run solver and see what happens. So I'm going to say solve, and then what happened? And okay, I have now profit has gone up. So profit went from 7668 to 7886. So it is higher. So the profit is higher, and we could see that the numbers are different now. Here, what we could say is that maximum profit increased. Maximum profit will increase from what to what? From 7668 to 7886.75. Okay. Okay. So now what about number 6? Instead, if the available hours in cutting and dyeing is decreased by 50, then what will happen to the maximum profit? Okay, so now let's go over to to a new one. So I'm going over to a new one, and then here now I'm going to decrease this by 50, right? Because that's what it says. Decrease it by 50. So here I'm going to make it 580. 580 and here. So then let's see what happens. Let's see what happens. So I go over to solver and I just click on solve because I don't need to change anything here. So I click on solve and then it says now it's 7449.25. And so now here we would say, okay, well then now the max profit will decrease to 7449.25. Okay, so again, you have now slightly different optimal solution. So this is like adjusting to the amount of the resources changing. Okay, and let's go over to number 7. Number 7, A7. So here it says, how about if there are 50 additional hours in the sewing department? How about in the sewing department? Sewing department. Where's the sewing department? That's over here. Okay. So if this number is increased by 50, will it give us more profit? You think? No, you don't think so. Why not? Well, I already have some left over, so I'm not actually using up all of what I have, and so I got 600, and I'm able to use only 480. So what is the point of getting more? I can't even use up the resource I already have. And so here, just by using some reasoning, some logic, you could say that I don't think that's going to make any difference. So we expect no change in profit. Because there is still some leftover, i.e. slack is positive. So having more resource should make a difference. Okay, but we could of course just check to make sure we are right. Okay, now which one am I talking about? Oh, sorry, this one. That's sewing. I could change it to 650. 650, okay. 650, and then I could run it again, and did it make any difference? Nope. So we verified it. So here we could say no difference in profit. Okay, so now let's go over to 8. So here it is. What if the unit profit of deluxe is actually 12 rather than 9? And will this change the optimal solution? Will this change the optimal solution? So deluxe is, right now it's 9. So for some reason, deluxe is less profitable than the standard. So it's only $9 it's going to bring you. So what if this is higher? Maybe if the deluxe is more profitable, then the solver will tell us to make more of the deluxe, maybe less of the standard. So we might think, let's try changing it. Okay, so here I'm going to change it to 12 and then see what happens. So I'm going to change here, and then I'm going to again go over to solver and solve it again. Just hit solve and say okay. And what happened? Does it change the optimal solution? Oh, no, right. So that's the same as before. This is the same. This is the same. Now, of course, profit changes because here I'm making, like instead of $9, we're making $12 per unit. And so the profit will change, but the optimal solution itself doesn't change. Okay, so here we would say no change in solution. No change in solution, though the total profit increases. Okay, well, what will it take? So what will it take to change this from 542 to 52? Okay, let me make again, a copy of this. And I'm going to try some different numbers. Okay, so I'm going to put this over here. That's my old solution, original. Then I'm going to now try 13. Okay, so I try 13 and see if that does anything. So solve it again. Did it change the solution? Oh, no. 14? Will it change the solution? Nope. Let's try 15. And is it change? Oh, okay. Something happened here. So something between 14 and 15, there's a change. Like there's a shift. There's a shift there. So now it's 304.20. I'm making more of the deluxe than before, making less of the standard than before. Okay, so let's take a look at the question here. Now, what if the unit profit is actually $16? And so that is higher than 15. So it's going to give us this new solutions. We're going to put here 16, and then we're going to solve, and then so this is what we get. So in this case, we get what's going on here is now the optimal solution. What's this? Optimal solution changes to, what does it change to? A 304.20. 300, and D is a 420. So 304.20.